Hello everyone. In last few lectures, we discussed the topic sensitivity in great detail. Now, let us discuss some questions asked on sensitivity in previous year GATE, engineering services and other competitive exams. So let us see the first question on sensitivity. So the first question is the sensitivity of transfer function T, which is given A1 plus KA2 upon A3 plus KA4 with respect to parameter K is given by, and you have the four options. Now this question was asked in ISRO EC 2018. So let us now find the solution of this question. So we have to find the sensitivity of the transfer function T with respect to K, and we know the formula. It is given by dou T by T upon dou K by K, and we can write this as K upon T into dou T by dou K. Now we have already discussed the formula of sensitivity in the previous lecture. Those who have not seen the previous lecture, the link to the lecture is in the I button. So my now main aim is to find the value of dou T by dou K. So let us find the value of dou T by dou K. We have already given the transfer function value T, and it is nothing but dou. We have the value of T as A1 plus KA2 upon A3 plus KA4. We need to differentiate this with respect to K. Now since the transfer function is in polynomial form, we can use the quotient rule, that is nothing but U by V rule of differentiation. The formula of the quotient rule you can see on the screen. Now can consider this is my U function and this is my V function. So by solving dou T by dou K, you will get it is V, which is A3 plus KA4 into differentiation of U, it will be 0 plus A2 minus U, it is A1 plus KA2 into differentiation of V, which will be 0 plus A4 upon V square, which will be A3 plus KA4 whole bracket square. Now you can just open the bracket, we will get dou T by dou K is equal to, we will get A2 A3 plus A2 KA4 minus A1 A4 minus A2 KA4 upon V square A3 plus KA4 whole bracket square. So we can cancel these two terms. So final answer of dou T by dou K will be A2 A3 minus A1 A4 upon A3 plus A4 whole bracket squared. Now we have to substitute this value of dou T by dou K in the equation of sensitivity. So we can get sensitivity of the transfer function T with respect to K is equal to K upon the value of transfer function t is given to us, and it is a1 plus a2 upon a3 plus a4 into value of dou t by dou k is nothing but a2 a3 minus a1 a4 upon a3 plus a4 whole bracket square. So you can cancel this term and one term from this will be cancelled. So the final answer of sensitivity T with respect to K will be K into A2 A3 minus A1 A4 upon A1 plus A2 into A3 plus A4. So this is the last answer for this question, and if you check the options, this is nothing but option number A. So the correct option for this question was option number A. Now let us see the question number 2, and it says, as shown in the figure, a negative feedback system has an amplifier gain of 100 with plus minus 10% tolerance in the forward path and an attenuator of value 9 by 100 is in the feedback path. You have to find the overall system gain. So we have given the figure. So we have a negative feedback system as shown in the figure. The forward gain is 100. So we can write the value of G of S is nothing but 100. And the feedback path is 9 by 100. So this is nothing but the value of H of S, which is nothing but 9 by 100. Now in question, it says the feedback system has an amplifier gain of 100 with plus minus 10% tolerance. So this plus minus 10% tolerance is nothing but the variation or change in the forward gain path. So I can write rho G by G is nothing but plus minus 10%. So now let us find the solution of this question. Now this question was asked in GATE Electrical 2010. Now before solving the solution of this question, let us first analyze the question in order to get some more information about this question. Now in question they have mentioned amplifier gain of 100. Now 100 is called amplifier gain because value is greater than 1. Any value of a gain which is greater than 1, we call it as an amplifier gain. And if the value of gain is less than 1, we call it as an attenuator gain. So here they have said attenuator of value 9 by 100. Now 9 by 100 is less than 1, hence they have used the word attenuator. So I hope you have understood this basic concept from this question. So now let us start and find the solution of this question. Now here we have to find two things. First is we have to find the transfer function, which is nothing but the system gain T, and also we have to find the change in transfer function when the forward gain path changes or varies by plus minus 10%. So we have to find T and the value of plus minus rho T by T. So let us first find the transfer function T which is also called the system gain. So I can write system gain is nothing but output upon input, which is nothing but our transfer function. And the transfer function of a closed loop system is G upon 1. Since it is a negative feedback, I have to write the plus sign plus GH. So you can substitute the value. The value of forward gain G is 100 upon 1 plus 100. Value of H is 9 by 100. So you can cancel this 100 and this 100. So we get it is 100 upon 1 plus 9, which is nothing but 100 by 10, which is nothing but 10. So the value of transfer function or system gain is 10. So if you see, we have the value of system gain 10 in all the 4 options. In option A, B, C, D, everywhere we have the value of system gain, which is 10. So we cannot directly mark the answer just by finding the system gain value. So we need to find the value of dou t by t in order to mark the correct answer. Now let us find the value of dou t by t. We know the sensitivity S of a transfer function t with respect to the forward gain block G is given by dou t by t upon dou G by G. So we need to find the value of dou t by t. The value of dou G by G, which is the change in forward gain path, it is 10%. So in order to find dou t by t, we also have to find the value of sensitivity of this transfer function. And we know the value of sensitivity of a closed loop system is nothing but 1 upon 1 plus GH. So we have all the values, so we can substitute the value. It will be 1 upon 1 plus G is 100, H is 9 by 100. So we will get the value of sensitivity as 1 upon 10. So now since we have the value of sensitivity, we can now easily find the value of dou t by t. So the value of sensitivity, we found it was 1 by 10 is equal to dou t by t upon change in the forward gain path dou G by G, it is plus minus 10%. So we can say dou t by t is nothing but plus minus 1%. So the value of transfer function or system gain is 10 and the change in transfer function due to variation in forward gain block is plus minus 1%. Let us check the correct option. The correct option is option A. Now since we have marked the correct option, which is option number A for this question, let us have some important concepts from this question. Now we can say the value of dou t by t which we got was plus minus 1%. This is the value in overall change in transfer function due to change in forward gain path which was 10%. Now since the forward gain path is changing by 10%, our transfer function is changing only by 1%. So this is an advantage due to the negative feedback. So we can write this is an advantage of feedback system, that is, even if there is variation in forward path G of S, which is plus minus 10%, the overall transfer function is affected only by 1%. So this is an important analysis from this question. Also, we can say earlier the gain of the forward path system G of S was 100, but the gain of the transfer function later became 10. So you can say whenever you apply a feedback, gain value is decreased. So with this simple analysis, let us go to question number 3. Now the question number 3 is, in a closed loop control system, what is the sensitivity of the gain of the overall system M to the variation in G? This was asked in Engineering Services 2009. Now this is a very easy question. There is no need to solve anything. Now normally our transfer function is given by t. Here they have taken the variable m. So that is the only change. Our transfer function variable is t, but they have said the variable is m to the variation in g. So we know the sensitivity of a closed loop transfer function is nothing but 1 upon 1 plus gh. So option B is the correct answer. We have already derived this equation in lecture number 7. I will put this link in this I button. You can see the answer for this question. So now let us go to question number 4. So the question number 4 says, steady state error for a negative unity feedback system is given by ESS, that is beta upon K. Then the sensitivity in steady state error with respect to beta and K is, and you have this 4 options. Now you must be saying, what is this steady state error? Now we are just discussing the basics of control system. We have a complete chapter on steady state error. So we'll discuss steady state error in that chapter. Steady state error is represented by ESS. So let us find the solution for this simple question. Now first he is asking to find the sensitivity of a steady state error ESS with respect to beta. So the sensitivity of steady state error with respect to beta will be dou ESS upon ESS upon dou beta upon beta. So I can simply write this as beta upon ESS into dou ESS upon dou beta. So I can simply substitute the value. I can write this beta as it is. ESS, it is given in question. It is nothing but beta upon K. So beta upon K into differentiation of ESS. So it is dou ESS is beta by K with respect to dou beta. So we'll get it is beta upon beta by K. So differentiation of beta by K with respect to beta is nothing but 1 by K. Now everything gets cancelled. This K, this K, this beta, this beta. So you have only left with answer 1. So the sensitivity S of a steady state error ESS with respect to beta is 1. Similarly, we have to find the sensitivity of steady state error ESS with respect to K now. So we can write sensitivity S of steady state error ESS with respect to K is equal to dou ESS upon ESS upon dou K by K, and you can write this equation as K upon ESS into dou ESS upon dou K. So again, just substitute the value of K as it is. ESS is nothing but beta upon K into differentiation of ESS. ESS is nothing but beta upon K, and differentiate this with respect to K. So you will get it is K upon beta upon K. Differentiation of beta by K with respect to K will be minus beta upon K square. So I can write this as K square upon beta into minus beta upon K square. Again, everything will get cancelled, and we have minus 1 as the answer. So the sensitivity of steady state error ESS with respect to K is nothing but minus 1. So we have one answer as minus 1, and sensitivity of ESS with respect to beta is 1. So we have answer 1 comma minus 1. So the correct option is option number B. Now let us see question number 5. The question says, consider the feedback control system shown in the figure. The normal value of process parameter K is 1. So the value of K is given to us, and it is 1. Evaluate or find the sensitivity of transfer function T of S is nothing but C of S upon R of S to the variation in parameter K. So what we have to find? We have to find the sensitivity of transfer function T with respect to K. This is what we have to find. Now the only change in this question is that we have not directly given the transfer function. We have given a block diagram of a unity feedback system, and we first need to find the transfer function from this given block diagram. Let us find the solution for this question. Now we are told to find the sensitivity S of transfer function T with respect to K. We have to find this value. Now to find this value, first we need to find the transfer function T. Since the transfer function is not mentioned in the question, we have given this block diagram of a unity feedback system. So the closed loop transfer function of a unity feedback system we have already studied. It is G of S into 1 plus G of S. Now we have a controller and a control process. We have the value of G of S, but we cannot ignore this block. You can consider this block as G dash of S. So combining G dash of S and G of S, we will get the value of G of S. So I can write this as 25K into S plus 1. Since these blocks are in series, they get multiplied upon, we have in denominator S plus 5 into S plus 1. This is our G of S. upon 1 plus g of s. So again 25k into s plus 1 upon s plus 5 into s plus 1. So this is nothing but our closed loop transfer function. Now we have to evaluate this in order to get the transfer function value. So we will get this as 25k upon s plus 1 upon s plus 5 into s plus 1 upon, I can write this as s plus 5 into s plus 1 multiplied by 1. I will get as s plus 5 into s plus 1 plus 25k into s plus 1 divided by s plus 5 into s upon s plus 1. So I can cancel these two terms. So we will get 25k into s plus 1 upon s into s plus 1 into s plus 5 plus 25k into s plus 1. Now since we have s plus 1 in numerator and s plus 1 in denominator, I can take s plus 1 as common. So it will be 25k s plus 1. I will take s plus 1 common in denominator. So it will be s plus 1 in bracket. It is s into s plus 5 plus 25k. So again you can cancel this s plus 1 and this s plus 1. So finally the closed loop transfer function T of s for the given unity feedback system is 25k upon s into s plus 5 plus 25k. If you want, you can just open the bracket. You will get 25k upon s square plus 5s plus 25k. So this is the last transfer function. So this is the transfer function of closed loop unity feedback system. Now since we have got the value of transfer function t, we can find the sensitivity s of transfer function t with respect to k, and we know the formula. It is dou t by t upon dou k by k, which is nothing but k upon t into dou t by dou k. Now I will not going to differentiate this dou t by dou k. I will directly write the answer of sensitivity. Finding the differentiation of transfer function t with respect to k is an homework for you guys. So directly I will write the answer. It will be s into s plus 5 upon s square plus 5s plus 25k. Now the value of k is given to us. The value of k is given in question as 1. So the final answer of sensitivity of transfer function t with respect to k will be s into s plus 5 upon s square plus 5s plus 25. So this is the final answer for this question. Now you must be knowing in all questions on sensitivity, the key point is finding the differentiation value of the given transfer function. So if you have a good command on differentiation, any question on sensitivity will be very easy for you to solve. Now let us see question number 6. It says determine the sensitivity of the overall closed loop transfer function for the system shown in the following figure at omega is equals to 1 radian per second with respect to first forward path transfer function and feedback path transfer function. So we need to find the sensitivity of a closed loop transfer function with respect to first the forward path and second with respect to feedback path. Now I will solve the sensitivity of transfer function with respect to first the forward path transfer function, and you will find the sensitivity of closed loop system with respect to feedback path. You will solve this question and you can write your answers in the comment section. So first part I will solve. The second part you need to solve and write the answer in the comment section. So from this figure I have two blocks. So this is nothing but my forward path, which is nothing but g of s, and its value is 25 upon s into s plus 2. And I have a feedback path 0.25, this is nothing but my h of s. So let us find the solution for this question. Now solution for the first part, it is to find the sensitivity of overall closed loop transfer function with respect to forward path g of s is given by, we know the formula, it is s, the sensitivity of overall transfer function t with respect to forward path g, and we know the formula is 1 upon 1 plus g of s into h of s. We have the values, it is 1 upon 1 plus value of g of s is 25 upon s into s plus 2 into value of h of s is 0.25. Now if you solve this, you will get the answer as s square plus 2s upon s square plus 2s plus 6.25. Now in the question we are told to find the sensitivity at omega is equals to 1. Omega is nothing but radian per second. It is the angular frequency. Now we need to replace s by j omega. So I will get, I have to replace s by j omega in this block. So I will get it as j square omega square plus 2 into j omega upon j square into omega square plus 2j omega plus 6.25. Now we know a j square value is minus 1. So I can write it as minus omega square plus 2j omega upon minus omega square plus 2j omega plus 6.25. The value of omega is given to us. It is 1 radian per second. So substitute the value of omega, so we will get it is minus 1 square plus 2 into j into 1 upon minus 1 square plus 2 j into 1 plus 6.25. So we will get 1 plus 2j upon 1 plus 2j plus 6.25. So I can write the sensitivity S of transfer function T with respect to forward gain element G is equal to 1 plus 2j upon 1 plus 6.25 will be 7.25 plus 2j, and if you solve the answer it will be something around 0.398. So this is the final answer for first part of sensitivity of closed loop transfer function with respect to forward path g of s, and the answer is 0.398. Now the answer of second part, which is nothing but the sensitivity of transfer function with respect to the feedback path element h, you need to find the answer the same way as we have did in the part 1, and you have to comment your answer in the comment section. So we have solved some good examples on sensitivity, and I hope you have a clear idea on questions asked on sensitivity. If you want to solve more questions on sensitivity and all other topics, you can join the WhatsApp group. The link for the group is given in the description. So here we completed the topic sensitivity. In next lecture, we will study the basic of Laplace in order to study the transfer function.